Okay, YouTube, in this video I'm just going to be looking at some homework exercises that I assigned here. And in these, what we're going to be doing, really looking at inverse trig functions, or in other words, what we're going to be looking at are angles. Because one thing that is very important, remember, is that when we discuss inverse trig functions are angles. Inverse trig functions are angles. And so really what's going to happen here is kind of the opposite of what happens with a normal trig function. Normal trig functions, we get an angle, and we can use a unit circle or whatever tool we have here to go and evaluate that trig function at that angle and give you a sine or a cosine value. What we're going to be doing here is starting with some value like the square root of 2 over 2, and then really going backwards and asking this question, what angle could give us this value of sine, say here, of root 2 over 2. So one thing I want to point out here is essentially this. Remember, when we're asking this question here, what is the angle that gives us a value of root 2 over 2, a sine value of root 2 over 2, we can go around the outside of the unit circle and look at all the sine values. And essentially, I can see there are 4 different places around the unit circle where sine has a value of just plain old root 2 over 2, positive or negative. And of course, that occurs wherever we have a 45-degree reference angle. But one thing that's really important to recognize here is that of these two angles, 45 degrees and 135 degrees, that give us a sine value of root 2 over 2, the one that we're actually going to keep is just the 45-degree marker there, or the pi fourth radian measurement. Now the reason why is because, and this is pretty important here, that we need to remember that with respect to sine functions here, you know what, maybe I can color code this here. With respect to arc sine functions, it always has to give us an angle back between positive 90 and negative 90 that gave us some sine value. And so what we're really going to be doing here is looking at between negative 90 and positive 90, which one of these angles gives us a positive root 2 over 2 for our sine value. You can see that that's just at a 45-degree angle there. Moving forward with cosine inverse. Now cosine inverse is a little bit different. Cosine inverse must tell us an angle between 0 and pi, or 0 and 180 degrees, that gives us some specific cosine value. And so maybe I'll color code this here. Our cosine is kind of like this teal color here. We're asking what angle between 0 and 180 degrees gives us a specific cosine value. And if you can see this here, we're saying really what's cosine inverse of a half, or really what angle between here and here gives us a positive a half on our cosine value. And you can see that we get a positive a half on our cosine value at a pi third radian measurement, or a 60-degree angle. So basically on all these, what we're going to be doing is going through and indicating which angles would make this true. So looking at a tangent value. Tangent, remember on the unit circle, to find tangent, we say that the tangent of an angle is really y over x, or another way we could look at this is we could take the sine value divided by the cosine value. But that being said, essentially we're asking where could tangent equal 1, and I think it's very useful to know your tangent values up here. If we were to take y divided by x that are 45 here, root 2 over 2 divided by root 2 over 2, what you would see is that we would just get 1 for a tangent value. Maybe I'll put this in a different color here. Oops, wrong button here. There we go, 1. The tangent of a 60-degree angle is root 3 when we take root 3 over 2 divided by a half, and the tangent here, or 1 half divided by root 3 over 2, is root 3 over 3. But with respect to what we're looking at here, we say, well, which of these angles between negative 90 and positive 90? Tangent is very much like sine in the angles that it gives back here. But which one of these angles between positive and negative 90 here gives us a tangent value of negative 1? And you can see that it would have to be down here in this fourth quadrant here, where we get all of the same values for tangent. It's just that because we're taking a negative y divided by a positive x, we get negative values down here in this quadrant. So we would say that the angle that would give us a negative 1 for a tangent value here would be a negative 45-degree angle, or a negative pi fourths. We say negative 45 degrees or negative pi fourths. Okay, so let's keep looking at these here. We'd say, okay, number 4, what angle is it between negative and positive 90 that gives us an arc sine, or a sine value of root 3 over 2, negative root 3 over 2? And I'd say between these two angles here, looking at our sine values, looks like it must be a negative 60 or a negative pi thirds. So really this is all we're doing on all of these, is running through and determining the angle that would give us these specific trig function values. Now the one I want to look at here, specifically number 5, we'd say what angle were you that gives you a cosine value of negative a half? And here's the thing we need to pay attention to. There are many angles that gives us a cosine value of negative a half. One here at 120 degrees, another one here, let's see, negative a half for cosine down here at 240, and we could find infinitely many coterminal angles with those two, but we'd say which angle between 0 and 180 gives us a cosine value of negative a half, and we could see that that occurs at 120 degrees right here, or 2 pi thirds. So we say 120 degrees or 2 pi thirds. 2/3. Okay, so for the rest of these, you're just going to run through and indicate the angle that is either between negative and positive 90, that gives you a specific trig value, and that's for sine and tangent, or an angle between 0 and 180 for cosine that gives you a specific cosine value. So, but the only other one I want to talk about here before I tune on this video is something like number 7, where we say, well, what's cosine inverse of 1? And really what we're asking is, what angle did you take the cosine of and get a value of 1? And so when you look on this interval here from 0 to 180 degrees, when we're looking at cosine values, we're looking at x values, and I can see that my cosine value is 1 at 0 radians, or 0 degrees. So every once in a while, you're going to come up with an angle that lies on one of the quadrants. And just recognize that happens when you get things like here, like a 1, or a 0. Cheers.